Welcome to aminacademy.com. In physics, regarding wave motion, let us do some solving problem. Look at these examples. A horizontal cord of 6 meter long has mass 1.6 gram. What must be the tension in the cord if the wavelength of a 130 hertz wave on it is to be 65 centimeter? How long a mass must be hung from its end to give its this tension? Look at here. Here the given things first. Mass. Mass equal 1.6 gram, which is equal 1.6 into 10 raised to minus 3 kg. Next. Length. Length is equal length of cord equal 6 meter. And frequency F equal 130 hertz. Now let us start the problem. We know that velocity v equals speed of the wave lambda f, which is equal lambda is 0.65 and wavelength lambda equal to 65 centimeter, which is equal 0.65 meter. So which is equal 0.65 into hertz equal 130 frequency, which is equal 84.5. We know that v speed equal, having another formula, is square root of tension in the string divided by mass per unit length. Now squaring both, v square equal square root will go, that is tension T over mass per unit length, which is equal from this tension equal v square into mass per unit length 1.6 into 10 raised to minus 3 over 6 meter length, unit length 6, which is equal 84.5 into 84.5, because it's square, 1.6 divided by 6 into 1000, because 10 power of minus 3 come down, which is equal 1.904 Newton. Now that is tension is force, Ft, tensile force equal mg. From this we can get mass that is hung equal m equal ft over gravity. Ft is 1.0 1.904 9.81, which is equal 0.194 kg. That means this 0.194 kg of the mass should be hung from the end to give that tension. Next question. A string fastened a string fastened at both ends resonates at 420 Hz and 490 Hz, two frequencies with no resonance frequencies in between. Find its fundamental resonance frequencies. Here, in general, Fn equal NF1. Now, from that, Fn equal 420 Hz and Fn plus 1, the second frequency, 490 Hz. In between, no resonant frequencies. Now, first 420 Hz, which is equal NF1, and 490 equal N plus 1 F1. Therefore, that is here subtracting this both, that is 490 minus 420, which is equal that is 70 Hertz. Therefore I had to find the fundamental resonance frequency, that is F1 equal 70 Hertz. Next question. A violin. A violin string resonates in its fundamental at 196 Hertz. Where along the string must you place your finger so its fundamental becomes 440 Hertz? That means this problem says first fundamental frequency is given on 96, then we have to produce second fundamental frequencies of 440 Hertz. For that, where you have to keep your finger next to it. That means how much the distance between them. So the first fundamental frequencies for that. In fundamental frequency, you can say total length L equal half lambda for violin. Then and lambda equal to P by frequencies. We have F1, fundamental frequency F1 is V over 2L. Originally, the string length L1 resonate to the frequencies 196. Therefore, 196, the fundamental frequency, 196, which is equal, hence is equal V by 2L1. And next frequency is 440. 440 Hertz equal V by 2L2. So look at here, this division of both, that means L2 by L1 dividing both equations, we have L2 over L1. L2 over L1 equals 196 over 440, which is equal 0.445. That means we obtain the desired resonance. The finger must shorten the string to 440.445 meter of its original length. So to get your resonance, to get your desired resonance, you have to place your finger at 0.445 of its original length. That means if you keep your finger back to 0.445 of its original length, we can get it there in between another resonant. Next question. A glass tube that is 70 centimeter long, open at both ends. Find the frequencies at which it will resonate to sound waves that have a speed of 340 meter per second. That is, the open tube is given with 70 centimeter long, and find the frequencies at which it will resonate to sound waves that have a speed of 340 meter per second. Here, look at here. The glass tube, that is length. Here, this L0 is 2 times 1 by 4 lambda. That is antinodes, this node. If it is half length on one side closed, this is node, this antinode. Here L is equal 1 by 4 lambda. Here first, a pipe that is open to both ends must have an antinode at each end. Antinode at each end. It will therefore resonate like here. Antinode, here node. Here 3 antinodes. In between nodes. And third, there are 4 antinodes. Next frequencies, there are 4 antinodes. In between nodes. Now let us start. L equal n times lambda n over 2, which gives lambda n equal to L by n. Where n is an integer, where that is an integer. Therefore, that we have lambda n equal v over fn. Therefore, fn equal n over 2l into v, which is n into 340 is v over 2 into 0.7 meter, which is equal to 43 n. Hence, that is here. Find the frequency at which it will resonate to sound waves that have the speed. And if speed of the sound is 340 meter per second, in this condition, for that is 70 centimeter long tube, open both ends, then it is this frequency, Fn natural frequency becomes 243 times n is an integer. Yes. So far we discussed some problems regarding wave motion considering sound waves. We have done. Please subscribe our YouTube channel.